The universe is a symphony of forces, each playing a crucial role. Gravity binds planets and stars. The strong force holds atomic nuclei together. And then there's electromagnetism, the force behind everything from the light we see to the technology we rely on. At the heart of electromagnetism lies a fundamental principle, Amperes' law. Imagine invisible lines of force swirling around a wire carrying an electric current. These are magnetic field lines, and Amperes' law gives us a way to understand and predict their behavior. It's like having a key to unlock the secrets of magnetism itself. Amperes' law tells us that the strength of a magnetic field is directly related to the amount of current flowing through a wire. More current, stronger magnetic field. It also tells us about the direction of the magnetic field, which circles around the wire like a dancer around a maypole. This law is crucial in physics because it helps us understand how electricity and magnetism are intertwined. It's a fundamental building block for technologies like electric motors, generators, and even medical imaging devices like MRI machines. Do you understand? Scientists love to express the elegance of the universe in the language of mathematics. Amperes' law is no exception. It can be written as an equation, BDL equals sign M0I. Don't let the symbols scare you. This equation simply states that the line integral of the magnetic field, B, around a closed loop, is equal to a constant M0 times the current, I, enclosed by that loop. Think of it like calculating the total magnetic push along a circular path around a wire. The stronger the current flowing through the wire, the greater this magnetic push will be. This equation allows physicists to make precise calculations about the strength and direction of magnetic fields in various situations. It's a powerful tool for understanding and designing electromagnetic devices. Do you understand? Now let's take our understanding of Amperes' law a step further and explore a fascinating application, the solenoid. Imagine taking a wire and coiling it up like a spring. Congratulations, you've just created a solenoid. This simple device is a fundamental building block in many electrical appliances and scientific instruments. When an electric current passes through the solenoid's coiled wire, something amazing happens. It generates a magnetic field. But this isn't just any magnetic field. The solenoid's coiled structure concentrates the magnetic field lines, creating a much stronger and more uniform field inside the coil. Think of it like this. Each loop of wire contributes its own little magnetic field. These individual fields add up inside the solenoid, creating a powerful and focused magnetic force. Do you understand? Section 4. The dance of electrons, currents effect on a solenoid. As electrons flow through the wire of a solenoid, they set in motion a remarkable transformation. The solenoid, once an unassuming coil of wire, becomes a magnet. This transformation is a direct result of Amperes' law. Remember how a current-carrying wire generates a magnetic field? In a solenoid, the magnetic fields produced by each loop of wire reinforce each other, creating a much stronger overall field inside the coil. The direction of the current determines the direction of the magnetic field. If you point your right thumb in the direction of the current flow, your fingers will curl in the direction of the magnetic field lines inside the solenoid. This ability to create a strong, controllable magnetic field makes solenoids incredibly useful. They form the heart of electromagnets, which are used in everything from lifting heavy objects in scrapyards to controlling the flow of current in sophisticated electronic circuits. Do you understand? Section 5. Turning up the magnetism, strengthening a solenoid's field. Imagine you have a solenoid and you want to make its magnetic field even stronger. How would you do it? Here are a few tricks of the trade. 1. Crank up the current. Just like turning up the volume on your stereo, increasing the current flowing through the solenoid's wire will directly increase the strength of the magnetic field. More current means more moving electrons, which means a more powerful magnetic force. 2. Add more coils. Think of each loop in a solenoid as a tiny magnetic field generator. Adding more loops or turns to the coil will increase the overall strength of the magnetic field inside. It's like adding more voices to a choir. The combined effect is more powerful. 3. Choose a different core. The material inside the solenoid's coil can also influence the magnetic field strength. Replacing the air inside the coil with a ferromagnetic material like iron can dramatically increase the magnetic field. These materials act like magnetic amplifiers, enhancing the field produced by the solenoid's coils. Do you understand? Section 6. Amperes' law in action. calculating a solenoid's magnetic field. Now let's put Ampere's law to work and calculate the magnetic field strength inside a solenoid. Imagine a solenoid with n turns of wire per unit length carrying a current I. Using Ampere's law, we can derive the following equation for the magnetic field, B, inside the solenoid. B equals MEO times N times On. This equation tells us that the magnetic field strength is directly proportional to the permeability of free space, M0, the number of turns per unit length, N, and the current, I, flowing through the wire. This simple yet powerful equation allows scientists and engineers to design solenoids with specific magnetic field strengths for a wide range of applications. Do you understand? Section 7. Conclusion. The power of electromagnetism. From the invisible forces that guide compasses to the powerful magnets used in medical imaging, electromagnetism shapes our world in countless ways. Ampere's law provides a fundamental understanding of this force, allowing us to predict and manipulate magnetic fields for technological innovation. The humble solenoid, with its ability to generate and concentrate magnetic fields, exemplifies the power of this fundamental law. By understanding the principles of electromagnetism, we unlock a universe of possibilities. Do you understand?